Hey guys, welcome to a 2017 Level 3 Integration exam walkthrough. Okay, so I'm going to get straight into it. Question 1. Find the integration of 4x squared 2x dx. Alright, so for this question we're going to be looking at our differentiation table, but this time we're going to be going backwards. Okay, so we're going to be going from a gradient function and we're going to be going back to a function. Okay, so we have 4x squared 2x, okay, so sec squared, okay, you should see sec squared on your differentiation table, and if you move back, it should give you the tan, okay? So you know there will be something tan something. But notice that, for example, when you differentiate something, for example, we say, let's say, for example, we differentiate 2 tan of 2x. Notice that when you differentiate the inner function here, you differentiate, so you get 2. So that differentiates to 2, and then you do 2 times 2, so that becomes 4 tan of, not tan, but that becomes 4 sec squared of 2x. So you multiply by whatever the derivative of the inner function is. So but this time we're going to be doing the opposite, okay? So you have 2x, and if you do the derivative of 2x is 2. So therefore, this 4 needs to be divided by 2. So that 4 will be divided by 2. So that will become 2 tan of 2x. So the integration of 4 sec squared 2x dx, that equals 2 tan of 2x plus c. Don't forget the plus c. That is very crucial to getting the maximum grade, which is achieved. Okay, but it's really important that you don't forget the plus c at the end. Alright, that's an achieved question, by the way, just an achieved. Alright, use integration to find the area enclosed between the curve y equals to x squared plus square root of x, a whole thing divided by x, and the lines y equals to 0, x equals to 1, and x equals to 4. That's therefore the area shaded in the diagram below. Alright, so to find the area under a graph, okay? So to find the area of the graph, you need to go from a function. So right now you have a y equals to something, and then you integrate to get an area function, okay? So when you differentiate the y, it will give you the area function, and use that area function to find the area. However, we need to find the area between 1 and 4 of this graph. So therefore, we're going to be using, so how am I going to explain? So I'm going to put it's going to be, if I substitute 4 into the area equation, and minus whatever 1 substituted into the equation is, okay? So it's easier if I show you. So first we need to find what the integration is, okay? So we're going to say the integral of 4 and 1, so that basically just means what I just said. So the 4 substituted into our integral minus 1 substituted into our integral, okay? That's what the small 4 and 1 means, okay? So bigger number always at the top, smaller number always at the bottom, alright? So x squared, sorry, what am I doing? X squared plus square root of x whole thing divided by x dx. Alright, so we need to simplify this a little bit before we can integrate. So right now we are unable to integrate this function. We need to simplify a bit more. We need to get rid of the x at the bottom, and we need to get rid of that square roots, okay? We don't like square roots, okay? So integral of 4 and 1, so we can say x squared plus x to the power of 0.5, that we can rewrite square root of x as x to the power of 0.5. And we can say the whole thing multiplied by x to the power of negative 1. We move the x on the denominator to the top, so therefore the positive power becomes a negative power dx. So now it's we simplify a bit more. So integral integral, that will become, so when you multiply powers, you add, okay? So basically when you multiply a power, you add the powers, okay? So 2 plus of negative 1, that just becomes x, plus x 0.5 plus negative 1, that becomes x to the power negative 0.5, and dx. Now we're ready to integrate, okay? Now we have all the suitable requirements in order to integrate. So now it's just really basic integration is what we have here, okay? Basic, okay? So you add 1 to the power, divide by the new power. So, that's just, so the x here, the x is going to become x squared divided by 2, and the x to the power of negative 0.5, so you add 1 to the power, that becomes x to the power of 0.5, and divide by the new power, so that becomes x to the power of 0.5 divided by 0.5. And if you simplify this, okay, I'll just give you 2x to the power of 0.5, okay? So that's your integral. You must be asking why is there no plus c, okay? The plus c only, this is a definite integral, okay? So when you're doing one, for example, we're going to substitute 4 into this area function, and we're going to minus 1 into our area function. Since both of these, if we minus 4 from the 1, both of these will have the plus c. So plus c and the plus c cancel out, so there's actually no need to write the plus c in this case, okay? But in all other cases, if you're not finding a definite integral, then you need to add the plus c, okay? But in this case specifically, we don't need to actually add the plus c, it's not necessary. Alright, so that becomes our integral, and now we're just going to find the difference between 4 and 1, okay? So I'm just going to make this a bit neater, so I'm just going to say it's actually x squared divided by 2 plus 2 times of square root of x, okay? That makes it a bit more prettier, if I should say. Alright, so now we can find what our answer is. Okay, so first we substitute 4 in, so 4 squared is 16, 16 divided by 2 is 8, so 8 plus square root of 4 is 2, 2 times 2 is 4, so 8 plus 4 minus 1 substitute into our equation, so minus 1 divided by 2 is 0.5, plus square root of 1 is just 1, so plus 2. So therefore, we should be getting our answer as 12 minus 2.5. And if you get your answer, you should be getting your answer as 9.5. And don't forget the unit, you can just say it's unit squared. And that should be your final answer, 9.5 units squared. And that will actually give you an achieved grade. It's a cheap question there. Yeah, achieved. Moving along. An object's acceleration is modeled by the function a of t equals to 1.2 times square root of t, where a is the acceleration of the object in meters per second and t is the time in seconds since the start of the object's motion. If the object had a velocity of 7 meters per second up to 4 seconds, how far did it travel in the first 9 seconds of motion? Alright, so once again we're coming back to our kinematics. So we need to integrate from acceleration to velocity, okay? So we need to integrate what we have here. We can rewrite this, okay? So once again, we don't like square roots. Square roots are annoying. So we're going to rewrite this as 1.2 times of t to the power of 0.5. So now we can really easily integrate. So we can say the integral of 1.2 t to the power of 0.5 dx, and that equals to you add 1 to the power and you divide by the new power. So t to the power 1.5 divided by 1.2 times of t to the power 1.5 divided by 1.5 plus of c. So we need to find out what c is. So if the object had a velocity of 7 meters per second after 4 seconds, okay, so that's what it's telling you. So v equals to 7 when t equals to 4. So that's v of t. So now 7 equals to 1.2. T is 4, so that's 4 to the power of 1.5 divided by 1.5 plus of c. And now all we need to do is do some calculator work here. Just bear with me while I get my calculator out. So 4 to the power of 1.5 times of 1.2 and divided by 1.5. That gives you the answer of 6.4. So now you know that c must be 0.6. So now your v of t, you know it's 1.2 times of t to the power 1.5 divided by 1.5 plus 0.6. Now you know that that's your now you know that's your velocity formula. So now we need to go back to the question. So how far did it travel in the first 9 seconds of motion? We need to go from velocity formula to distance formula, and we need to integrate again. So now s of t, okay, s of t equals to 1.2. Okay, so now once again you move the power up by 1, so that becomes t to the power of 2.5, and then you divide by the new power. But then you just move to the denominator, so that becomes 1 divided by 1.5 times of 2.5. And then we're going to add the 0.6t, and we're going to add the c we don't know, okay? So if we simplify this a little bit, so we can say s of t equals to 1.2 t to the power of 2.5 divided by 1.5 1.5 times 2.5, so 1.5 times 2.5 divided by 3.75 plus 0.6t plus c. Okay, so how far did it travel in the first 9 seconds of motion? So basically, when the t equals to 0, our distance equals to 0, so therefore our c equals to 0. So we're just going to make that statement. We're going to say that when t equals to 0, s equals to 0, therefore c equals to 0. Okay? So now we can say, we can find out what s of 9 seconds is. So s of 9 equals to 1.2 times of 9 to the power of 2.5 divided by 3.75 plus 0.6 times of 9. And once again, it's just simple calculator work from here. Remember to add brackets when necessary. If you're not confident in completing everything in one line, then split it up into different one at a time. Okay. Divided by plus, and you should begin your final answer as 83.16 meters should be your final answer, and that should indeed be your final answer, and that should be a merit question to get the correct distance. To get an achievement, you're finding the correct v of t with the c. Okay, v of t with the c, so that's v of t with the c here. That's an achieved. All right, moving along. Find the value of k if the integral of so basically k substitute into our integral minus 0 substitute into our integral, 3e to the power of 2x dx equals to 4. Alright, so for this question, okay, you need to integrate, and you need to first you need to integrate your function, and then you need to substitute k into the formula, minus 0 substitute into the formula, and that equals to 4. And you rearrange the equation to find for k. Alright, so integral k and 0. So 3e to the power of 2x. Okay, so how are we going to integrate that? So for example, we're going to come back to our differentiate example again. I'm going to give you an example. For example, we have e to the power of 2x. You know that we differentiate this, we differentiate the power, and we add the power, we multiply the power of the coefficient, okay? So the differentiation of 2x is 2. So therefore, and then we keep the power the same. So it becomes 2e to the power of 2x. That's for differentiation. But now for integration, we do the opposite. So looking at this 2x here, if we differentiate 2x, that is equal to 2. Now instead of multiplying by 2, we just divide by 2. So therefore, integral of that. So 3e to the power of 2x dx equals 4. And that equals to, so just basically now just becomes 3 divided by 2. 3 divided by 2 e to the power of 2x. Once again, we don't need the plus c because it's a definite integral, okay? And k and 0, that equals to 4. Now we need to substitute k into our formula, minus 0 substitute into our formula. So 3 over 2 e, x substitute for k, so it becomes e to the power of 2k minus 3 over 2 times of e to the power of 0. And that equals to 4. Now we're just going to simplify this a bit more. So 3 divided by 2, e to the power of 2k. Okay, so e to the power of 0 is just 1. 1 times of 1.5, that should be 1.5. Let me check that. 1 times, yeah, it's 1.5. Sorry, that's so stupid. Sorry, that's 1.5. Okay, so if you move the negative 1.5 to a side, it becomes positive 1.5. So 4 plus 1.5 is just 5.5. So 3 over 2 e to the power of 2k equals to 5.5. We'll move the 3 over 2 to the other side. So e to the power of 2k equals to 5.5 divided by 3 over 2, which actually equals to, should be 5.5 divided by, that should give you the answer of 11 over 3. So now we know that e to the power of 2k equals to 11 over 3. Alright, so basically there's 2 ways you can do this. It's either take logs of both sides, or you can move the e to the other side, it'll become ln. It's really your choice, but in terms of the standard, I'm going to use the ln way. Okay, so I'm going to say 2k equals to ln of 11 over 3. So therefore k equals to ln of 11 over 3 divided by 2. And if you simplify that, just plug into a calculator, find the ln button, simplify, and you should get your answer as 0.6496 should be your final answer there. And this is a merit question. To get an achieved question, you're looking for correct integration. So correct integration you're looking for is here. So correct integration will get you an achieved. Alright, next question. The mean value of a function y equals to f of x from x equals to a to x equals to b is given by mean value is the integral b minus a of f of x dx divided by b minus a. Find the mean value of y equals to sine squared x between x equals to 0 and x equals to pi. Part of the graph has been shown below. Alright, so basically for this question, okay, it tells you your function, so that's your f of x. So that's your f of x here, and your x equals to 0 and x equals to pi. Remember that the bigger number is always at the top, okay? So this will actually be b, and this will actually be your a value, okay? So, okay, once again, to find, we need to integrate, okay? So now, we need to find the integral between pi and 0 of sine squared x dx. Right, so you know that you actually can't simplify it right now. You need to go back to your formula sheet. Well, you could integrate sine squared x, but if you integrate it like you would normally, you actually get an answer that if you differentiate back, you won't get sine squared x, which is the problem. So therefore, we need to rewrite sine squared x as something else. Okay. So if you go to your formula sheet, okay, so that's should be the level 3 formula sheet. Sorry, just let me find it. Level 3 formula sheet. Sorry guys, just forget resource. Okay, so you should be finding on your formula sheet. You should know that okay, so you should know that cos of 2x is equal to what am I doing? 1 minus 2 sine squared a. So therefore, you can rewrite in terms of sine squared, not a, what am I doing? It's x. So you can rewrite your formula to find in terms of sine squared x, okay? So you should find that sine squared x equals to 1 minus cos 2x divided by 2. If you rearrange, that's just basic algebra. Moving the 1 across and then divide by -2. That's just your algebra there. And that should give you that sine squared x equals to 1 minus cos 2x divided by 2. So now you can rewrite sine squared x in your integral as 1 minus cos 2x divided by 2. So your integral now becomes 1 minus cos 2x divided by 2 dx. So now this is a lot easier to integrate. Okay, so I'm just going to simplify once again, just get rid of the 2 on the bottom. So that becomes 0.5 minus 1/2 of cos 2x dx. So if you integrate, okay, you find, okay, so 0.5, the integration is just 0.5x minus 1/2 of cos squared x. Remember what I said before? You need to differentiate your inner function, and then that's 2. So now you do 1/2 divided by 2. So 1/2 now becomes 1/4 of, okay, so integrate cos, okay. So looking back at your formula sheet, okay, you should see that cos will go back to sine. So that just becomes 1/4 of sine 2x. And that will be your integral. And that will be between pi and 0. So now you need to find the value of pi, substitute into your formula, minus 0, substitute into your formula. So 0.5 times of pi minus 1/4 sine of 2 pi. And we're going to minus, so just put this into brackets, minus 0.5 times of 0 minus 1/4 of sine 0. Alright, so we just simplify this now, so that just becomes 0.5 pi minus 0.25. Sorry, actually. So sine of 2 pi. sine of 2 pi is 0. Okay, so that just becomes 0.5 pi minus 1/4 sine 0. Sine 0 is 0. Okay, sine 0 is 0. So therefore, this comes out to be 0. So therefore, that would become 0.5 pi minus 0, which equals to 0.5 pi. Right, you're not quite done yet, okay? So basically what you found now is this value at the top here of the numerator. All you have to do now is just find the numerator, which you just found, 0.5 pi divided by the denominator b minus a. So you have your b value and your a value. Pi minus 0 is still pi, so we're just going to say that the mean value, so we're just going to say m equals to 0.5 pi divided by pi, and pi's cancel out, so this just becomes 0.5. And you should get 0.5 as your final answer, and that will get you an excellence grade. And to get a merit grade, you're looking for correct integration of the sine squared x. So sine squared x integrated correctly will get you a merit. So up to here will get you a merit. And there's no criteria for an achieved. You cannot get an achieved for this question. And that will actually get you an excellence grade. Alright, thank you for watching this video. I'll post question 2 and question 3 in a future video. Stay tuned for that. But thank you for watching this video, and I'll see you in the next one. Thank you. Bye.